Hi, this is the third video in the playlist where we're looking at the Edexcel paper from November 2017. It's actually paper 3, calculator paper. In the previous video we completed through to question number 13, so we're going to start from this video from question number 14 onwards. Please do stop the video, have a go at each of the questions and then compare your solution. Okay, so let's look then at question number 14, which is a mathematically similar type of question. These again are very popular, they do come up quite frequently. So what we've got is cone A and cone B. Now I'm always advocate drawing a little sketch. Okay, I'm not great at sketching, but basically you've got cone A and then you've got, in this particular case, a much smaller cone B. Now the reason I know that is because it says the ratio, the volume of cone A to the volume of cone B is 27:8. So what we mean by that is if it's 27:8 and it's a volume, that's actually the coefficient cubed, and that's a key issue that you need to remember, that the coefficient for volume is actually cubed. Now if you're not sure about this, if you have a look on the channel, there is a playlist on mathematically similar shapes. Okay, the bit I'm interested in, however, is the k squared term, because that is the surface area that I'm looking at. So what I'm going to do is, if I cube this number and this number, I'm going to get k on its own. Now while it doesn't help me too much and I don't really need it, at least it does tell me this is the linear relationship. So if we're looking at vertical height or diameter or something like this, I'd be able to cube 8, which is going to give me 2, and cube 27, which is going to give me 3. Okay, however, I'm interested, as I mentioned before, in the k squared or surface area coefficient. So if I square this, I'm going to get 4, and if I square this, I'm going to get 9. And this is the bit that I'm interested in. Okay, because what we're saying is that k squared is the surface area ratio. Okay, so area ratio. So the surface area of cone A is 297 centimeters cubed. Show that the surface area of cone B is 132. Well, okay, so we've got A and we've got B, okay, and we're saying that the ratio is going to be 9:4, okay. Well, if in reality the actual surface area of A is going to be 297, then it's 33 times bigger. Okay, 9 times 33 is 297. So I need to show that actually if I multiply this by 33, I get 132. So therefore, I'm showing that the surface area of cone B is 132 centimeters squared. Okay, so a bit of a tricky one to start this particular video with. This whole paper is actually quite a difficult paper, but hopefully you've been able to score some marks from that particular question. Okay, and again, if you do have a look on the playlists on the channel, there are some playlists on mathematically similar shapes. Okay, so let's have a look then at question number 15a. Show that the equation has a solution between 0 and 1. All right, what we mean by that is that the value of x is going to be 0 or 1 in order to make this final answer to be 0. Okay, so a little bit complicated. I think the way they explain these is not always particularly easy to kind of understand, but what we mean is that when x equals 0, if we plug it into this equation, x cubed plus 7x minus 5, then that's going to equal minus 5, because 0 cubed plus 7 times 0 is still minus 5. He's got minus 5 there, so the value is going to be minus 5. Okay, so the next one then is when x equals 1. So again, I'm going to plug this into x cubed plus 7x minus 5. So that's going to be 1 cubed plus 7 times 1 minus 5. So that's going to give me a value of 3. Okay, so minus 5 to 3 is somewhere either side of 0. Okay, this is a lot lower than 0, and this is a lot more than 0. Okay, so therefore we're showing that the solution is when x is between 0 and 1. Okay, so a little bit complex to follow those sorts of the way they word these things, but hopefully that's been okay. This whole particular topic is called iteration, and it does mention right at the very big bottom there you've got the iteration formula, and again I have just posted a playlist on iteration on the channel, so please do have a look at that one. So show that the equation can be rearranged to give that. Well, basically all we're saying is that can we get one of these x values to be the subject of the particular formula. If we make that the subject of the formula, then we can use that to be able to calculate the value of x, and that's really the meaning behind iteration. Okay, so what I would say is, well, at the moment I've got x cubed plus 7x minus 5. Well, I spot that is going to be a positive value of 5, so basically I'm going to say, well, okay, that's the same as saying x cubed plus 7x equals 5, because if I add 5 to both sides, that will disappear and go to the other side. Okay, now it's not always the easiest thing to do with these, but if I look at this, I can actually factorize that for x. So if I factorize that for x, I'm going to get x squared plus 7 equals 5. Okay, and then if I divide both sides by x squared plus 7, I'm going to get x equals 5 divided by x squared plus 7. And that would be the answer to this particular part B. Okay, and then the final part C is starting with x subset 1 equals x 0 equals 1. Use the iteration formula 3 times to find an estimate for the solution. Now, you'll see on the playlist on iteration formula, it varies. Sometimes they talk about to get it to a certain number of decimal places. In this particular case, we've just got 3 times. So actually, we can start with x subset 0 equals 1. And then x1, all we're doing is we're taking this value and plugging it into the formula. So these questions, they are quite wordy to do, but really they're quite simple, providing you've got a calculator, okay? And that would give you 0.625. So then we're taking this value of 0.625 and we're plugging it into here, okay? So progressively, we are refining our answer. So x subset 2 is 5, and I usually use the answer key in the calculator, plus 7, and that's going to give us 0.676532. And it is important that you write down all the numbers with these sorts of calculations. So final one, okay, I've got answer squared. Now remember, this answer is this number here, so you can type it in if you want to, it doesn't really matter. It's just easier to use the answer key if you've got a scientific calculator, and that's going to give me 0.670448. Now there is an explanation on the playlist about iterations to what we're actually doing here, okay? So I'm just going to move on a little bit to part D, and it says, by substituting your answer to part C, comment on the accuracy. So all we're doing is we're saying, well, actually, rather than x cubed plus 7x minus 5, okay, equals 0, I'm going to put this value of the previous calculation. It's actually this one here, okay? So I'm just going to plug it straight into here. I'd write that as something like, I don't know, you could write it all out if you wanted to, just for the sake of expediency. I'll put answer cubed plus 7 times answer, okay, minus 5, and that equals, in this particular case, minus 0.0 005497. Okay, so comment on the accuracy of that. Well, it's pretty accurate. Okay, it's accurate because it's within 5 thousandths of the answer. Okay, so it's pretty accurate as that one. 5,000 is perfectly fine. Okay, no problem. Let's move on then to a bounds question, which is going to be question number 16. I'm going to aim for this video to complete in probably about 20 minutes or so, but please do stop the video, have a go at each of the questions, and while the video is about 20 minutes, it should give you about an hour's worth of fairly focused revision. So the petrol consumption of a car in litres, blah, is given by that formula. Nathan's car travelled 148 kilometres, correct to 3 sig fig. Okay, I would stop there if I were you. Okay, so I won't worry about the rest of it, because when it says correct to 3 significant figures, we're really talking about bounds. So let's have a look at 148. Okay, so with 148 we've got the upper bound and the lower bound. It's always better to go to the lower bound first. If that number is correct to 3 significant figures, it means the lower bound is 147.5. It also means the upper bound is 148.5. Okay, and then the next one is the car used that amount of fuel, correct to 3 significant figures again. So I'm going to do exactly the same. I'm going to say, okay, well, that's fine, no problem. So I've got 11.8, and again I'm going to put lower bound and upper bound. Now you notice at this point I haven't even read the rest of the question. I just know it's going to come up. Okay, so lower bound is going to be 11.75 because the third significant figure is 7. 5 is the lowest it can be to trigger that changing to 8. Okay, upper bound is going to be 11.85. Now remember, with bounds we're not talking about rounding. So again, if you have a look on the channel, there is some videos on rounding of significant figures and bounds and all that sort of stuff. Okay, so let's have a look now at the formula. Okay, so Nathan says my car used less than 8 litres of petrol per 100 kilometres. Okay, all right, so let's look at the upper bound. So the upper bound of the amount of fuel, we're going to use the same formula that we've got there, but what we're basically going to say is that it's going to be the maximum amount of fuel for the minimum amount of petrol is going to give us the upper bound. So it'll be 100 multiplied by 11.85 divided by the minimum amount of fuel that went in. Okay, sorry, the minimum amount of kilometres travelled, I beg your pardon, I'm so sorry. So that's going to be 147.5. all right, so if you calculate that through, that's going to give you 8.034. Let's look now at the lower bound. So with the lower bound, what we're looking at is achieving the maximum amount of kilometres for the amount of fuel that we use and the lowest amount of fuel. Okay, so that's going to be 100 multiplied by 11.75, and that's going to be divided by 148.5. Pop that into your calculator and you're going to get 7.91. Okay, so actually we've got a variation here. Use less than 8 litres of petrol. Well, yes, if it's the lower bound of fuel. However, if it's the upper bound, it's slightly more. So I would put something like Nathan could be incorrect, and if you wanted to just quote the lower bound and upper bound, that's perfectly fine with that. Okay, so we're 14 minutes into this particular video. Let's have a look then at question number 17. It's getting a little bit more tricky now. Please do stop the video, have a go at this particular question. Okay, this particular question we're told that the area of the triangle ADC is 56 meters squared. So that's actually this ADC, is this bottom triangle here, is going to be 56 meters squared. Okay, so we can kind of use that to be able to work out a few things. So the first thing I'm going to do is I'm going to fill out the bits of information that I've got. Okay, so What I do know is that if this is 118 and this is 48, then it must mean that this is 14 degrees. Okay, so I know that I'm going to need to use that a little bit later on. So let's have a look then at ADC. Okay, so ADC equals 56. And what do we know about that? Well, we actually know that we've got a half AB sine C to work out the actual 56 meters squared area. So if we look at ADC, we know that A is going to be 11 and we know that sine C is going to be sine of 105, but the problem we're going to have is that we actually don't know this over here, which we can call B or we can call it CD. But we've got the process, or we've got the ability then to be able to kind of figure that out because we know the total of area is 56. So let's try to plug this into the equation and see where it gets us. Okay, so I've got 56 equals a half, and rather than writing A, I'm going to write 11. And then rather than writing B, I'm going to write CD because that's the bit that I'm interested in at the moment. But I do know that that's going to be multiplied by the sine of 105 degrees. Okay, so once I calculate all of that out, I can say that CD equals, and it's a half times 11, which is 5.5, and 5.5 times sine 105 is going to be 56 divided by 5.5 times sine 105. Okay, so that's going to give me a value of CD is going to be 10.54 meters. Now that's going to be important to me. I can use that bit of information to figure everything out. So this value CD here is going to be 10.54, and if I want to put in the rest, 0.99384. Okay. Right, so once I've got that, I can then use this bit of information to figure out AC. Now, the reason I want to know AC is because they're asking us to work out AB. So what I can do, once I've got AC and I want to work out this bit along here, I can use the sine rule. So the next bit of this particular calculation is to use the information I've got, which is going to serve me very well to work out AC. And then I can say, well, actually, I can relate 118 degrees to this length AC and then 48 degrees to this length over here. Okay, so let's have a look first at how we can calculate AC. Well, the way to calculate AC, so this is ADC, AC is going to be, we can use the cosine rule for it. So I can say that A squared, which is going to be, well, we'll come to it in a minute, A squared equals B squared plus C squared minus 2BC cosine A. Okay, so let's plug in a little bit of information. So B squared is going to be, in this particular case, I'm going to make it this one. This is why I'm not so keen on labelling up diagrams too much. But I'm now going to change that to B, okay? And I'm going to change that to C. And I'm going to say, well, actually, A squared is going to be this length along here, okay? So B squared is going to be 11 squared plus, well, C squared is going to be that. So I won't write out all of that. I'm just going to put CD squared, okay, minus 2 times B, which is 11, times C, which is CD, times the cosine of 105 degrees. Okay, whack that into a calculator and I'm going to get that A squared equals 292.1331702. So at long last, if I square root it, I can figure out that AC, which is the information I need, is going to be 17.091 90364. Okay, and that's fine. All right, so what I've got now is the ability to use the sine rule. So what I'm going to do is I'm just going to recreate this top triangle for you just at the bottom of the page, and that'll show you why I needed to get to that value of AC. So basically, we've got this triangle. It looks something like that. Okay, so this is A and this is C, and we've just figured that out, so we know that is 17.09 something or other. Okay, what we also do know is we're going to say that actually I've got this value here which is going to be 48, and I've got this value here which is what I'm looking to achieve, which is AB. But they have told me that this is going to be 118. So as it turned out, I didn't need to calculate that, but I did anyway. Okay, so now we've got that, I can just use the straightforward sine rule, and I can say that A over the sine of A equals B over the sine of B. Now, I appreciate it looks a little bit confusing because I've got A, B's and C's floating around all over the place, but it's only really because the way that they ask these sorts of questions is they tend to label them up in such a way that it can be very confusing, because I'm not actually going to use the information I've got. I'm going to say that this is A, okay, and this is A now. So I've got A over the sine of 48 degrees equals B, which is fine, is going to be 17.09 ... divided by the sine of 118 degrees. Okay, so I can now calculate that for A itself by multiplying this by sine 48, or multiplying both sides by sine 48. So what I'm going to get is going to be A equals sine 48 degrees multiplied by 17.09 ... oops, divided by the sine of 118. Okay, when I pop that into my calculator, I'm going to get 14.385 ... Okay, so the answer to the question is that AB equals 14.4 meters. Okay, so quite a difficult question. I'm very aware that that's sort of gone on for quite some time to actually get to this, but it is halfway through what is a very difficult paper, or 2/3 of the way through a very difficult paper. So hopefully if you've managed to kind of work through this whole idea of using the area formula, half AB sine C, then using the cosine rule, and then using the sine rule to actually get the answer at the very end, then you've done extremely well. It is a very, very tricky question to keep everything juggling away. Okay, so I think at that point we should stop there. I hope it's been useful for you. I appreciate it's a fairly short video, but it'll give you the opportunity to go over and have a look at some of these questions again if you need to. So from video number 4, we're going to start from question number 18, and I look forward to seeing you inside the next video.